Hello everyone, my name is Rohit Singhal. We were discussing about the topic hydrocarbons. In the previous class, we have discussed about about some synthetic procedures, preparation of the saturated hydrocarbons, that is alkenes. In this class, we are now going to discuss about its properties, the physical properties, the chemical properties, their solubility, melting point, boiling point. All this we are going to discuss in this class. Okay, so the topic for today's lecture is properties of alkenes. Starting with physical properties. Okay. In general, if I talk about, let's say, okay, what are these? Carbon, hydrogen. These are the this is the mainly the bond present in the alkane. C bond is present, CH bond is present. These two bonds are present. Okay. If I talk about the electronegativity, so electronegativity of carbon is around 2.5. The electronegativity of hydrogen is 2.2. Here it is 2.5, 2.5. So what is there? Very less electronegative difference. This bond is so no difference. Okay. So carbon and hydrogen, there is very less electronegative difference between the two elements. So what it does, rise to an covalent bond. That's why it's an covalent bond. And what is this? Almost non-polar. Okay. So this is the two things, one or two things. Okay. So these are the one or two things that will decide the properties of the hydrocarbons, the alkanes. There is very less electronegative difference between these alkanes. That's why this rise to an covalent character of the bonds, and these are mostly non-polar, because the polarity is developed from the difference in the electronegativity of the two elements. This electronegativity I have given according to the Pauling scale. Okay. So one is this, the how the bond is, the property of the bond between the alkanes. The other thing we can discuss is, okay, force. These are bound by weak van der Waals forces. Okay. So these weak van der Waals forces are present. Due to this, what happens? The carbon 1 to carbon means methane. The starting members of this ethane C2H6, C3H8, C4H10 up to butane. These are gases. Okay. What happens? Carbon C5 onwards to almost, you can say, C16 or 17. These are liquids at room temperature. I am talking about. Okay. Room temperature. Methane is a gas, ethane, propane and butane are the gases. Above this, about C16, C17, these are liquids, and C18 onwards, these are solids. Okay. So there are very weak van der Waals forces present in the alkanes. So that's why the lower moieties of the list of the list are either gas or liquids. The first four moieties of the list are gases. Okay, due to the weak van der Waals forces present in them. Okay, so next we will discuss about solubility. We can discuss. So what are the solubility of it? Okay, this one mantra that goes for the solubility is like dissolves like. For example, what I am saying is, if we check in the solubility in water, for example, in water is a highly polar molecule, highly polar molecule. Okay. And alkanes are, on the other hand, I have already talked about, alkanes are almost non-polar. Okay, almost, they have got slight polarity, but almost obviously not as much as water does. Almost non-polar they are. So alkanes are not soluble in water. Alkanes are not soluble in water. So what are the solvents they are soluble in? Alkanes are soluble in what solvents they will be soluble? So they require non-polar solvents. They require non-polar solvents for solubility. Okay. And we have plenty of non-polar solvents in form of organic solvents. So alkanes are soluble in organic solvents like DCM, like dichloromethane, ethyl acetate, benzene. These type of solvents, these alkanes are soluble in. Okay. You must be wondering that why we are discussing about the solubility of alkanes, what you guys will be having use of it. Okay, there is one practical use of the solubility of the alkanes. Okay, you must have whenever there is some grease or something applied on the clothes, so grease, or we can say dirt, something like that. If there is one practical application of it, what is this? If there is grease on your clothes, on the clothes, so what happened is, if you are doing some work and some grease have been put on your clothes, so what happens is, if we normally wash the clothes, the grease is not removed. Why it is so? Because grease is also a mixture of hydrocarbons. Grease is a mixture of hydrocarbons. And hydrocarbons are not soluble, or hydrocarbons, I say alkane, yeah, hydrocarbons I can say. Okay. And these hydrocarbons are not soluble in water. So if we are gonna try washing the clothes just by water with the clothes with the grease, so it is not going to remove. So what we can do, petrol, it is normally used in the automobile as a fuel. The petrol that is normally used in the automobiles as a fuel can also be used as to remove the grease stain from the clothes. Okay, petrol can also, because this is also a mixture of hydrocarbons. Okay, mixture of hydrocarbons can also be used to remove grease stain, because these are also the non-polar solvent, and this can soluble, what we can do, it will solubilize the grease in itself and it will remove it. Can also be used to remove grease from the, or grease stain from clothes. Okay. So these are few physical properties of it. Okay. The solubility I have discussed. Okay, we can discuss also about the boiling points. Okay, the boiling point is an interesting thing. Okay, I have already taught the alkanes have weak van der Waals force. That means overall low boiling point will be there, low boiling point. But in the among the alkanes, how we will characterize this boiling point, means what how the trend goes on, how as the number of carbon increases or whatever it is. So how is boiling point going to change among the list of the alkanes? Okay, so we will discuss it. I have already taught that carbon number 1 to 4, these are gas. Carbon number 5 to carbon number, let's say 16, 17 it is, carbon number 5 to carbon number 17, these are liquid, carbon number 17, 18 onwards, okay, so carbon number 18 onwards, these are gas. That means on increasing the number of carbon, on increasing the number of carbons, boiling point increases. And why it is so? Reason, the strength of van der Waals force increases. The strength of, because the van der Waals force's strength depends on the weight, depends on the number of carbons. So if the number of carbons want to increase, the strength of the van der Waals forces will increase as the number of carbons will increase. Okay. So there is one thing we have discussed about the boiling point trend between among the number of, how the number of carbons increases. Let us say the effect, there is one thing we can study on the boiling points also, effect of branch okay. This I have discussed in the isomerism. Okay, what are the branches, or say, like example, there is one CH3, CH3, CH2, CH3, CH2, CH3. This is a butane. Okay, the another one is CH3, CH, CH3, CH3. It is 2-methyl. I have told the naming of all this. Okay, propane. Now, if you remember, if you go up through your notes in the previous classes, I have mentioned their approximately boiling points in that class. But now, if you don't know, means you can't remember all of the melting points or boiling points, na. So how you going to distinguish between, how you can say ki which one has got more boiling point or melting point? So what happens is both the carbons have same molecular formula. Okay. So what we have discussed, different number of carbons, but these have got same number of carbons. So what one can state till now, from the till now knowledge, it that is the same boiling point. Does this imply same boiling point? No, it does not have same boiling point. I have already told these two are the isomers. If these two are the isomers, this can only have the same molecular formula. This will have same different physical properties, different chemical properties, and boiling point is one of the physical properties. So one thing is for sure, that boiling point will be different. So how it's different, how we will differentiate it? So there is one thing, that the branching in the chain, branching in the molecule decreases the boiling point. The reason is again same, decreases the strength of van der Waals forces. Okay. So one thing is for sure, how the strength of van der Waals forces are going to change. If the number of carbons are increasing, the van der Waals strength will increase. If the branching is increasing in the chain, then the strength of van der Waals forces is going to decrease, and the boiling point and the melting point are directly dependent on the strength of van der Waals forces. Okay. So boiling point directly depends on strength of van der Waals forces, it's directly depend on the number of carbons present and it's directly depend on the, okay, say inverse, inversely proportional to, and it's inversely proportional to the branching in the molecule. Okay. So, what happened? The case I have discussed, butane 2-methyl propane, the molecular formula is same, but the branching is different. Butane has got the least branching. If the branching is less, the boiling point will be greater. So, the boiling point of normal butane is higher than that of 2-methyl propane, that is a branching is there. Okay. So, till now these are the things to remember. The physical properties I have told. One I have told about the physical properties, the electronegativity of these, force, van der Waals forces are present, how the states of the of this list of the members of the list are going to change on increasing the number of carbons. As we are going to increase the number of carbons, the strength of van der Waals force is going to increase. Then the solubility we have discussed. We have also discussed about the practical application of it. Okay. Then we have discussed the boiling point. Okay. So, these are basically the physical properties you must need to understand, and now we can discuss about the chemical properties of it. So, this concludes the physical properties of the alkanes. In the next class, we will cover the chemical properties, and then we will discuss about the properties of alkenes and alkynes. Okay. Thank you so much.